In this skill, we're again going to be converting between the current charge and time passed through an electrochemical cell and the amount of a substance that's produced. This time we're going to be looking at the grams of a substance that's produced or the grams of a substance that's used up. So same as last time, we're going to be using charge. We're going to be converting between charge and moles of electrons. And then we're going to be converting from moles of electrons to moles of the thing we're trying to find. I'm going to call that X here. However, we're going to add an extra step, which is converting from moles of X to grams of X, or vice versa. So we're still using charge to moles of electrons and moles of electrons to moles of the substance. We're just adding an extra step, which is moles of substance to grams of substance. We're also going to be using the Q equals IT equation in order to get our charge, or in order to use our charge to find out either the current or the time. So those are the steps we're going to be using. In this particular question, we're asked to determine how long a steady current of 17.4 amps needs to flow through the electrochemical cell in order to make 20.2 grams of solid gallium Ga. So in this question, we're starting with grams of gallium. I'm going to fill that in here. So we're then going to need to convert to moles of gallium next. Then we're going to convert from moles of gallium to moles of electrons needed. And finally, we're going to convert from moles of electrons to charge. Once we've got the charge, we're going to use that in the Q equals IT equation, along with the current provided in the question here, which was 17.4 amps, to figure out the time needed for that current to pass. Now, we've got 3 steps in our dimensional analysis, so we're going to need 3 conversion factors. The first is the conversion factor between grams of gallium and moles of gallium. Let's head to our periodic table on the reference sheet. Here's gallium. We can see that gallium has a relative atomic mass of 69.72 grams per mole. That means that 69.72 grams of gallium is equal to 1 mole of gallium. So that's going to be our conversion factor for our first step. Next step is going between moles of gallium and moles of electrons. To find that conversion factor, we're going to need to write a balanced half equation for the reaction involving gallium. So we can see in our equation here, we start with gallium 3 plus aqueous, and we end up with gallium solid. So we're starting with gallium 3 plus aqueous. We're ending up with gallium solid. We've got a charge of 3 plus on the left and 0 on the right. So if I add 3 electrons on the left, now my charge on the left is 0 and my charge on the right is 0. So that balances out. That's our balanced half equation. So we can see 3 moles of electrons are transferred in this half reaction. And we can see that 3 moles of electrons are needed to form 1 mole of gallium solid. So that's our conversion here. 3 moles of electrons are needed to form 1 mole of gallium. So there's our conversion factor for the second step. Then we're going to convert from moles of electrons to charge. Let's head to our reference sheet. Here's the Faraday constant. That tells us that in 1 mole of electrons, there's 96,485 coulombs of charge. So there's our 3 conversion factors we're going to need for this dimensional analysis. Then we'll have our charge and we'll use that in the Q equals IT equation. Our first step is converting from grams of gallium to moles of gallium. We're going to have grams on the bottom, so that will cancel out, and moles on the top, since that's what we're trying to get to in this step. Then we need to have the top and the bottom of the fraction equal to each other. So 1 mole of gallium is equal to 69.72 grams of gallium. In our next step, we're going from moles of gallium to moles of electrons. So moles of gallium is going to go on the bottom, so it will cancel out. Moles of electrons is going to go on the top. Then we need to make the top and bottom of our fraction equal. So 1 mole of gallium is equal to 3 moles of electrons. And we got that from our balanced half equation. Our next step is going from moles of electrons to charge. So we want moles of electrons on the bottom and charge on the top, so that moles of electrons will cancel out and we'll end up with charge, which is our goal. Then we have 1 mole of electrons is equal to 96,485 coulombs of charge. So now what we need to do is multiply everything on the top row, multiply everything on the bottom, and divide the top by the bottom. Grams of gallium will cancel out, moles of gallium will cancel out, moles of electrons will cancel out, and we're left with coulombs, which is our goal. So that gives us 20.2 multiplied by 1, multiplied by 3, multiplied by 96,485 coulombs divided by 69.7 multiplied by 1 multiplied by 1. If we put that onto our calculator, we get an answer of 83,864 coulombs of charge. Let's go ahead and fill that in here. 83,864 coulombs of charge. Awesome. So we've figured out how much charge is required to pass through the cell to produce 20.2 grams of solid gallium. Now we need to figure out how long we would need to pass a steady current of 17.4 amps to produce this charge. So this is where the Q equals IT equation comes in. Q equals IT. We're trying to find T, the time. Right now, time is multiplied by I, the current. So I'm going to divide by I on both sides of my equation so that that will cancel out, leaving me with T is equal to Q divided by I. Now we just need to put on our numbers. Q is the charge, which was 83,864 coulombs that we just calculated, divided by I, which is the current. That was given in the question as 17.4 amps. So if you put that into our calculator, that's going to get us out a time of 4,820 seconds. So we can go ahead and fill that in here. Awesome. Finally, it also wants us to give that in minutes. So we're going to need to convert that into minutes. So we've got 4,820 seconds. We use the conversion factor 1 minute is equal to 60 seconds. So we can set up our dimensional analysis table. Seconds is going on the bottom, so it will cancel out. Minutes is going on the top. We know 1 minute is equal to 60 seconds. We're going to multiply everything on the top and divide top by bottom. Seconds will cancel, leaving us with 4,820 multiplied by 1 divided by 60 minutes, which gets us an answer of 80.3 minutes. So we can go ahead and fill that out here. Awesome. So there's a lot of steps going on in this question, but it's essentially identical to the previous skill. We're just adding on the extra step of going between moles and grams. Start by drawing out your map. You're either going to be starting with charge and going to moles of electrons, moles of our substance, and then mass of our substance, or you're going to be starting with mass of our substance, going to moles of our substance, moles of electrons, and then charge. Remember, you're also going to need to use Q equals IT to either use your current and your time to find your charge at the beginning, or to use your charge along with the current or the time to find the time or the current. Remember, our conversion factor between grams and moles can be found by the molar mass of that substance from the periodic table on the reference sheet. The conversion between moles of our substance and moles of electrons can be found using the balanced half equation. And the conversion between moles of electrons and charge is going to be found using Faraday's constant.